Hey guys, I'm going to go over the Test 3A review for the upcoming test this week. It will be in ALEKS, and I also have a review sheet that will accompany it, just like the test will have a test sheet as well. So yeah, let's jump into it. So first question, what are the leading coefficient and degree of the polynomial? So in this polynomial, we have four terms, meaning that there are four monomials. There's 15, there's 12w, negative 10w to the ninth, and 8w to the eighth. The leading coefficient, well, of all these four terms, or of these four monomials, negative 10w to the ninth has the largest degree, 9. So this right here will be degree 9. So the degree of the polynomial will be the same degree as the largest monomial, and the leading coefficient will be the coefficient that's with it. So in this case, that will be negative, that's going to be negative 10. So that's the leading coefficient, and the degree is 9. We can check it, and there you go. If you need to keep trying more, keep trying more. So for this one right here, the degree would be 4, since that's the largest degree here, and the leading coefficient would be 1, since the leading coefficient of that term is 1. And there you go. So keep trying as many as you need to. For question 2, for each function, determine whether it is a polynomial function. So for A, is negative 1 a polynomial? Yes, because negative 1 is a monomial. A monomial can be a number, it can be a variable, or it can be the product of the two. So this is yes. For B, is this a monomial? We have 3x to the ninth, we have 0.4x to the fourth. That is fine because we have variables and their exponents are whole numbers and they're not negative. So that's a yes. For C, that is a no because we have a quotient with a variable in the denominator. Variables should only be in the numerator. And then for D, this would be a no because the last term has a x in the square root. So that would not be considered a polynomial. We can't have stuff like that in polynomials. Let's go ahead and check it. And we're good. Let's try another one. Maybe. Try another. There we go. For A, so we have 4 times x minus 4 times by x plus 2. Now this is in factored form, but if we multiply it out, it will be in standard form. So this is a yes. There's no problems with this right here, even if it's factored. For B, that's a no. It's x is under the square root. That does not mean that will make it not a polynomial. For C, that is also no because the first term that has a negative exponent. And for D, that's going to be no because x is in the denominator. Let's check it. And we're good. Let's see if there's anything else that's odd that comes up. So for A, that's a no. For B, that's a yes. Numbers are okay. For C, that's a no because the square root. For D, that's a yes because we have whole number positive exponents. So let's go ahead and check it again. All right, we're good. I think we've covered a lot of the possibilities that could happen. So for A, that would be a yes because the second term does have 8 in the denominator, but that's okay as long as the variables aren't in the denominator. But yeah, so I think we should be good there. For 3, choose the end behavior of the graph. So I'm actually going to take a screenshot of this right here, and I'm going to put this where I can draw some illustrations, and we'll see if that can help us here. So this is for 3 right here. Let me drop in the photo that we have. Okay, so for A, when I'm looking at A right here, choose the end behavior of the graph. So either whenever you have a graph, when you have a polynomial, it can fall on the left, or it can go up on the left, it can go up on the right, or it can go down on the right. It all depends on the leading coefficient and the degree. So for A, it depends on this term right here, and then it depends on this term for C. Now this one's kind of tricky because this is in factored form, but I can see that the leading coefficient is -2, and then if I count how many x's there are, there's 1, 2, now this counts as 2 right here because it's being squared. So 1, 2, 3, 4. So that means the leading term will be to the 4th degree. So this is what's important right here, these leading terms. So for A, if you have a positive leading coefficient and an even degree, or sorry, an odd degree. We have an odd degree. So the leading coefficient here is 6, the degree is 3. So if it's a positive leading coefficient, if it's an odd degree, then that means on the left side, it's going to have to fall. On the right side, it's going to have to rise and go up. So there is on your notes, if you check on the 3.1 notes, you should have this information on your notes. And if you don't have your notes filled out, then you can look at my notes on Canvas. But there is a page that has all the options. There's only 4 ways that it can go. It can fall on the left and rise on the right. It can rise on the left and rise on the right. It can rise on the left and fall on the right, or it can fall on the left and fall on the right. So only one of those 4. So it all depends on the degree and the leading coefficient. So again, odd degree, odd degree means they have to be going in different directions. Either one side's going to go up, one side's going to go down. And if it's a positive leading coefficient, that will tell me on the left side it's going down, and the right side is going up. Had this been a negative leading coefficient, so had this been -6, this would have been switched, where it went up on the left and down on the right. And so there's that right there. So this right here is going to fall on the left and rise on the right. So it's going to be that one. For this one right here, looks like we have a positive leading coefficient, that is 1, and we have an even degree, and that degree is 6. So if it's an even degree, they must be going in the same direction, and if it's a positive leading coefficient, that direction is up. So it has to be going up on the left and up on the right. So it has to rise on the left, but not fall. So rise on the left and rise on the right, so it's got to be that one. For this one right here, we have a negative leading coefficient, and that is -2, and we have an even degree. We have an even degree, so, and that degree is 4. So if it's an even degree, they have to be going in the same direction. If it's negative, they're both going down. So that's going to be fall, not rise, fall on the left, fall on the right, so it's got to be that one. So first, and then third, and then last. So first, third, and then last. Let's see if I get these right. Okay, we're good. If we need to try any more. Okay, so for A, we have a positive leading coefficient. That means it has to fall on the left, rise on the right, or vice versa. And then because it's an odd degree, that means it's going to fall on the left and rise on the right. Okay, for B, we have the same situation. So B and A are actually going to be the same, because we have a positive leading coefficient, which is the 3 out in front. We have an odd degree, which is the 3 for the power. So fall on the left, and it has to rise on the right. For C, now we have a -5. Now this is factored, so the degree will be, this one's going to be tricky actually. Oh no, not too bad. But I wish I could write on this right here. So negative 5x, 2x minus 5. So we have negative 5x? Or, yeah, negative 5x. 2x minus 5 squared is what we have. So this right here, the leading coefficient will actually be negative 5 and 2 times together. Ooh, the 2 is being squared, so it's going to be negative. Either way, the leading coefficient honestly doesn't matter what it is, except that it's negative. It's definitely going to be negative. Shouldn't matter what it is, but it is going to be negative because we have this negative 5. And then the degree is going to be 3. Because we have x and it's being squared, so that's going to be 2, and then times by x again, so that's going to add to be 3. So our degree is 3, so that means the ends have to be going in opposite directions, and because the leading coefficient is negative, that means it's going to rise on the left and it's going to fall on the right. So that should be good. Let's check it. Okay, we're good. Keep trying these. Again, there's only 4 outcomes, but try different variations. All right, for 4, we're being asked to simplify this expression right here. Let me go ahead and do a quick screenshot. And let me load it in here. This video is going to take a while just for me waiting on things to load. Okay, so this is for 4. We're going to simplify. So basically, we're just going to add and subtract. So we have x minus 6. We are subtracting, so that's going to distribute in. So it's going to be minus 2x squared plus 4x and then plus 6. So we have negative 2x squared. That's going to be the first term. And then we're going to have x and 4x. So that's going to be plus 5x. And then that's going to be negative 6 plus 6, that's going to be 0. So it should be negative 2x squared plus 5x. Let's see if this will work. This is not an Alex question. This is actually a question that has been generated by someone who made this. So I hope that this will work. So negative 2x squared. And then plus 5x. Let's see, plus 5x. I'm kind of worried about the formatting, but yeah, we're good. Maybe it's not. No, this is not generated by... No, this is definitely Alex generated. So in any case, so you might get addition or you might get subtraction. Just combine terms, like terms, and you'll be good. I think 5 is going to be similar. Just going to add, and so combine like terms. So I'm going to skip 5. I'm going to go to 6. All right, this one is definitely not Alex generated question. So we'll see how this one goes. Excuse me. This will go for 6. All right, and this one right here, we are going to be multiplying 3 binomials together. So whenever I multiply 3 binomials, I just start with 2 of them. So I'm going to start with these 2 right here. So whenever I multiply polynomials, every term in one has to add to every term in the other, and then I combine like terms if there are any. So the x is going to multiply by the 2x and get me 2x squared. The x is also going to multiply by the negative 1. It's going to give me negative x. So this term has multiplied with both of these, and I'm going to do the same with 3. I'm going to multiply 3 by both of these. So plus 6x and then minus 3. And then I'm going to combine like terms, which there are. So we have 2x squared plus 5x minus 3. Now I'm going to multiply this with the one that I just got. So 3x plus 2. And do the same process. So I'm going to multiply the 2x squared by both of these. The 5x by both of these. The negative 3 by both of those. So I'm going to start with 2x squared. So 2x squared by 3x is going to be 6x to the third. 2x squared by 2 is going to be plus 4x squared. And then, so I multiply this by both. Now 5x times by 3x is going to be 15x squared. So 15x squared. 5x times by 2 is going to be plus 10x. So I multiplied 5 by both of them. Then negative 3 by 3 is going to be negative 9x. And then negative 3 by 2 is going to be negative 6. And kind of notice how I stack these. I'm stacking all the like terms so that whenever I can just combine these terms right here and I'll get the answer. So 6x to the third plus 19x squared plus x minus 6. So let's see how this goes. So 6x to the third. So 6x raised to the third. And then we have plus 19x squared. So plus 19x to the power 2. And then plus x. And then minus 6. So where's the minus? Minus 6. See if this works. It worked. Yep, we got that check mark. Okay. You can't try another one of these, but if I were you, I would look at the homework, and on the notes there are some there. If you just redo those ones, then you'll be good to go. I think if you complete this homework assignment, then submit it, and then try again, you might get another one. I'm not entirely sure though. All right, for 7, it looks like this one's just the same. So go ahead and do 7 and do the same thing. I'm going to go to number 8. Looks like 8 is similar, just another practice one. Oh, that's why there's not another one. So there's 6, 7, 8. 6, 7, and 8 are the same, but on the test you should only get 1, maybe 2. But the test, there's only going to be 20 questions, not 23. So I think we just added more in for practice since we didn't pull them from the question bank. So I think that's why. Yeah. So I'm going to go to... So then in that case, I'm not really sure which one 9 goes under. I can check though. Kind of. Not really. Not right now anyways. Unit 3. Anyways, I'll just do this one under the next one. So 8 minus 7y, 8 plus 7y. So I'll do that here. So 8 plus, was it 7 or 9? 8 plus 7y, and then 8 minus 7y. So we're going to multiply these together. It doesn't really matter which way you write them. So when I multiply these together, you can do it the same way that we did it up here. But if you also recognize the pattern, you can always go for the pattern. But 8 times 8 is 64. Now the pattern is going to be this. 8 times negative 7y. 8 times 8, 64. Minus. I don't really know what 8 times 7 is. 7 times 21, 28. 28. 7 times 8, that's going to be 56. So minus 56y, but then when I multiply these together, I'll get positive 56y. And then I'll get, when I multiply these together, it's going to be negative 49y squared. These cancel, so I get 64 minus 49y squared. You're just using the difference of squares factoring pattern. So 64 minus 49y squared. There you go. So you can keep trying those. Again, keep trying until you get the pattern. So like this one's actually really easy. So this one's going to be z squared. And then it's going to be minus, it's always minus in between them, minus 100 because 10 squared is 100. So you can keep trying that pattern over and over. So this one, 3x squared, is going to be 9x squared. So 9x squared. And then we're going to do minus whatever 2 squared is, which is going to be 4. You can check it. Keep checking, just keep trying those until you get the pattern. For this one, 5v minus 6x squared. So 5v minus 6x squared. Now that's just the same thing as 5v minus 6x times by 5v minus 6x. So 5v times 5v is going to be 25v squared. 5v times by negative 6 is going to be negative 30xv. And then you'll get another one of those because that's the same product right here. So minus 30xv and then plus 36x squared. These can combine, so you get 25v squared minus 60xv plus 36x squared. I really don't want to type all that in, but that's what you would type in. Okay, for 11, okay, so multiplying two trinomials together. This one shouldn't be that bad, but it's just kind of lengthy. So my guess is that this right here is going to be what your question 7 is. This right here should be what your question 8 is. And then this question right here is going to be what your question 9 is. Okay. So here, multiply all 3 terms here with every term here. So I like to just start by with the first term, multiply all 3 terms. Then I go to the next term, multiply that, so on and so forth. So 5v squared times by 7v squared is going to be 5 times 7. I am so bad with multiplication. That's going to be 35, I think. Yep, 35 v to the 4th when I multiply those together. Multiply those together, I get negative 15v to the 3rd. And then that's going to be plus 30v squared. So I multiplied this by all 3 terms. Now I'm going to multiply v by all 3 terms here. That's going to be plus 7v to the 3rd. Notice how when I multiply these together, I get a 3rd degree. So I'm going to start stacking it underneath this column of numbers. And then v times by negative 3v is going to be negative 9v squared. And then plus 6v. So I'm just stacking numbers that are like terms. Then negative 6 times by all 3 of those. Negative 6 times by 7 is going to be negative 42. Then we'll have the v squared. Then we'll have plus 18v minus 36. So 18v. Did I get those right? So negative 42, negative 18, positive 36. Add them together, so 35v to the 4th. Then we'll have negative 15 and 7. That's going to be negative 8v cubed. Then we have 30, and then we have negative 9, and then we have negative 42. It's going to come out to be negative 21v squared. 18 and 6 is going to be 24. V, and then minus 36. So that should be the answer. Again, I'm not going to type it out. So for 12, that's going to be what's going for 10. So for 12, this is using Pascal's triangle. This is a good one to practice. So Pascal's triangle will be given to you guys on the AP exam. You will have that for you, so you don't have to memorize it. So I'll show you what you do here. I don't have it memorized, but I know the patterns. The patterns are really simple. So for a 0 degree, that's going to be 1, 1st degree, 2nd degree, 3rd degree, that's a 3 right there, 4th degree. So those are going to be the coefficients, 0, 1, 2, 3, 4. Okay, so using Pascal's triangle, which I kind of have right here, In fact, let's see if I can just find it in the set of notes. Let's go to 3.2 notes right here. So this is Pascal's triangle. So we have a 4th degree polynomial. I'll just grab this right here. So this is what I will use. So if it were you on the AP exam, this is what you'd be looking at. You'd be looking at using this line of Pascal's triangle, where for A, you have 2x, for B, you have 3. So this is what you're going to write out. You're going to have 1, I'm not going to write the 1 though, because I don't care to write that, but I'm going to have 2x to the 4th, just like how we have it here. Then we're going to have plus 4, and then we're going to have 2x to the 3rd times by 3. For 3 is going to be B. And then plus 6, then we would have 2x squared and then 3 squared. And then we'd have plus 4 times by 2x times by 3 to the 3rd plus 3 to the 4th. And then you will have to simplify this. So since this is a 4th degree Taylor polynomial and we have x right here, this will be x to the 4th. The next term is going to be x to the 3rd. Next term is going to be x squared. Next term is just going to be x, and the last number is just going to be some constant. So this is what our polynomial should look like in the end, but we do have to get the coefficients here, and we have to get the positives. This should all be positive since this is all positive. If it's ever negative, just pay attention to, so if this is negative, this would be -3, -3, -3, -3, and then you'll have to simplify as you go. But for the coefficients, this one's going to be 2 to the 4th. So we're going to raise 2 to the 4th power. 2 to the 4th power is 16. So that's what's going to go here. For the next one, that's going to be 4 times by 2 to the 3rd times by 3. So 4, 2 to the 3rd times by 3. So calculator will help here. So 4 times by 8 times by 3. So this next number is going to be positive 96. The next number is going to be 6 times by 2 squared times by 3. That should be squared right there, right? So we have 6 squared, yeah. So then that's going to be squared right here. So that's going to be 6 times 4 times by 9. So that's going to be plus 216. Then we're going to have 4 times 2 times by 3 to the 3rd. So that's going to be 8 times by 27, so that's going to be plus 216, and then this one's just going to be 3 to the 4th, and 3 to the 4th is at 80, that's 81. So then this constant right here, this is just going to be plus 81. So this right here is what you would type in for your answer. Okay? All right, I think that's halfway. The test is going to be 20 questions. And so, whoops, which question are we on? Which question did we do? That 12. So 13 would be the next question. This is just another practice. This is a Pascal's triangle, so if you need to practice more, you can practice more. What about 14? 14 is also another practice problem for that right there. For 15, okay, so for 15, that's what we're going to, that's going to be the next question. So I'm actually going to do a second video for the rest of the review.